This is an orthokeratology case where the patient's getting pretty good refractive vision and acuity, but having some trouble with glare at nighttime in dim lighting. And I'm going to bring up a pair of windows for the right eye. This is the same lens in both eyes right now, the current lens designed for the right eye. And one way to get a slightly larger treatment zone is to increase the OZ and IC positions, but there's not a whole lot more room, as you had mentioned in your email. Another way to kind of get a larger treatment zone is to add asphericity into the lens. And I'm beginning to do this a little bit more often than just increasing the optic zone of the lens. I feel like it works a little bit better. Neither one gives huge amount of change, but sometimes a little bit is just all we need to get the patient a little bit happier. So I'm going to just keep this one up in its original form so we can use it as comparison. And on this side, let's show you how we can add asphericity to the lens. We do have to turn the blending back on for this to work. Adding asphericity to the lens where the zones are not blended does not really give the effect we're looking for. So I am going to turn the blending back on, and we see we get a smoother curve now. And a good place to start, I think, is about 0.2, so plus 20, and you'll see that the center part of the curve takes on a fairly different shape now. We do want to look at the original lens and see that our original Atopia demands was 6.42. Adding the asphericity has changed that, so I'm going to change the lens in 100% mode to kind of match. I'm just going to decrease this until we're right around 642. Okay. Our lens power is significantly different from before, and that's just because of the optics of the asphericity. I wouldn't worry so much about the numerical value of the power, but I do want it to be fairly uniform all the way around the lens. I'm going to go into 25% mode, and we're at 1.54. If we click over, we can probably make this a little bit closer. And I'm just going to go through and try to even out the lens in all meridians. And that looks pretty good. Okay, we'll go back to 100% mode. We're a little bit different from the original topo demand. It's not a huge difference, but that is just a little bit closer. And we can go around the meridians and still confirm that the curves are pretty uniform around. Okay, so here's our new lens. And if we look at the original lens, the tear layer or the tear lens exceeded a depth of 20 microns at about 2.82, just inside the pupil. With the new lens, we've managed to kind of shift that back to about the size of the pupil. And so I think that'll give us a slightly larger treatment zone. Again, I don't think it's going to necessarily be a night and day difference with the glare, but it should be a little bit better. And as long as the patient has that knowledge ahead of time, the patient should be happy with the little bit of improvement we can get with nighttime vision. So I would employ the same thing for the left eye, just remove or adding back in the blending, adding in asphericity, and adjusting the topo demand and power to match the new lens. So hope this helps, and good luck with your patient.